the Castle Steam V6 boiler in a coal-fired boiler plant. The V6 is now on a baseboard and fitted with the Southworth Engines horizontal steam pump. The boiler also has a manual pump in case the steam pump ever fails. This is the baseboard that used to have my stainless steel 6-inch diameter boiler fitted to it. And as the fittings for the previous boiler were very different, in this clip I'm removing the mounting bolts. The layout is going to be fairly similar to my previous boiler. And here's a clip from Model Steam Engines for Beginners Part 5 showing the other boiler. Here you see me shutting the bypass valve, and what's going to happen now is water will start to be pumped into the boiler, and because the fire is very hot you won't get much of a pressure drop. In fact, the boiler is blowing off. The safety valve is set to blow off at 70 pounds per square inch, and it will blow off for about 20 psi and kick back in at 50. To stop it blowing off, simply open the fire hole door. You will notice if you open and shut the fire hole door with the blower active, there's a distinct difference in tone. I gave the boiler that you've just seen to my good friend Nigel, and he'll be selling it on eBay very soon. I don't need two 6-inch diameter boilers, and this Castle Steam boiler is the best of the bunch. In this clip you can see the proposed layout of the boiler and pump, and this is a Southworth 12-inch horizontal version of the boiler pump, which was built by my friend Don English, and I've featured it in a few videos prior to fitting it to this plant. Here I'm temporarily disconnecting the water bypass valve from the water pipe that's connected to the main check valve at the top of the boiler. I've removed the blanking plug, and now I'm fitting another check valve further down the boiler. And before I get any comments from people who don't know any better, this is not just any adjustable spanner, it is a Barco adjustable spanner. And these Barco spanners accurately fit the hexagon part of the nut or bolt, and you never round the edges. Although I haven't shown the lathe operation, I made a special adapter. It's just a union fitting, but I made it from phosphor bronze. I could have made it from brass, it would have been perfectly fine. I just happened to have a very small piece of phosphor bronze in the chip tray of the lathe. This adapter connects to the pipe that goes round the corner and up to the check valve at the top. This is one of 3 small pipe bending gadgets that I have, and this one has the facility to bend 1/4-inch pipe. I need to make a double bend in this, like an S-bend. And this is how I'm going to connect the hand pump to the second check valve. Bending copper pipe is a bit of an acquired skill, you need plenty of practice, and I still get it wrong even now. The problem is you can only bend pipe of this thickness once. If you bend it wrong, it's best to select a new piece of pipe. You could anneal the old piece of pipe by heating it to a red heat, but that slows the job down, and it's still maybe not going to look too good. The handle on this water pump that came with the other boiler is a bit too long really, and as you can clearly see from this clip, the bypass tap is in the way. Oh dear, what am I going to do? I have 2 options. Either I shorten the handle, or alternatively, I could loosen the union nuts and rotate the water valve through 90 degrees like this. Now this long handle only touches the check valve pipe when it's right at the end of its travel. To mount the water pump to the baseboard, it's quite simple. I've drilled 4 holes that are marked out by putting the pump in place and scribing through the holes. Then I drilled 4 holes down into the baseboard using a 5/32 of an inch twist drill. And this is tapping size for 2BA, and what I'm doing at the moment is threading the holes to take some 2BA bolts. I've mentioned before it's a good plan when doing a job like this to put some cyanoacrylate adhesive or super glue down into the holes to harden the threads, but in this case it's not necessary because there is no stress put on the mounting brackets of the pump. All of the stress is in the pump itself. I originally built this plant a while back, and this is a water fitting that I made. And the output of the water fitting that fed the original pump was threaded 5/16 by 32 threads per inch for 3/16 pipe. But as this water pump is much larger, I've opened it up and fitted a union so I can use 1/4-inch pipe. This is a piece of thick-walled silicone rubber tubing, and it's what I'm going to use to carry the water from the union to the pump. Time now to bolt the engine in place. I've cheated a bit really. I'm using very nice stainless steel hexagon bolts at the front, but at the back, where space was very restricted, I used a pair of 2BA crosshead type bolts that I could easily fit with a screwdriver. I've connected the flexible pipe that comes from the adapter at the rear to the push-on fitting that I made for the water inlet to the pump. A video like this wouldn't be complete without running the engine at the end. So here is the pump running on very low pressure. All I need to do now is just pipe the exhaust up the chimney. I don't think it needs to go to a condenser because this is not really going to be a gas-fired boiler, it's a coal-fired boiler most of the time. And the heat from the coal fire will just burn off the oil like it does in the steam locomotive. The mechanical lubricator setting is clearly over-oiling the pump, but I'm going to leave it that way because it's better to get too much oil than too little. Very shortly I will be testing this boiler plant on a special engine that I've bought. But for now, thanks for watching and I hope you found it useful.